Hey, hello, and welcome or welcome back. And in the last video, the one about bowling, I had talked a little bit about back burner projects, which I am a big supporter of. And it gave me the inspiration to go through all my back burner projects and find one to finish. Because I wanted to finish one. I mean, I've finished games before. I've published finished games before. I've made RC Bumper Boat Challenge and published that. Game Zolkeen and published that. And a zombie game. What the hell was the name of it? That was a couple of years ago. But it was like a zombie wave shooter game. Published that in an APK. And I've finished games before, but I've got so many on the back burner. I said I want to finish one because talking about it made me want to do it. Obviously, Ninjapop. Yeah, I love that. All right, so this game here, which is called obviously Ninjapop, was originally going to be Number Ninja, okay? And you were going to jump to like get numbers and stuff flying up, but it changed and evolved into this. And what it is you got this little ninja guy here, and as you can see, we got all these oriental glowing lanterns that float up. All right, and they give off little sparks. Each one has something, well, not each one, but the special ones will have things attached to them, like that timer that resets your time. Oh shit, I missed the katanas. Ninja stars, let's see if I can get it. There it is. And, katanas. There they are. That widens your range, which you'll hit a lot more. Ooh, got the time. And yeah, it evolved into this, which was going to be like a mobile game. And it's very basic. You just got to keep the time up and get points. And you want to get a high score. Ooh, I died. Which isn't normally the type of game I'm into. Just like getting a high score. But I thought it might be good for like mobile. And this is what we're going to be making today. And like I said, I've already made it, but I'm going to walking you through it, showing you how I made it, and how it's done. And if you want to try it for yourself, I published a build for like PC and Mac, that default build. I published that to a build and uploaded it to my Google Drive, and I'll post a link down below in the description so you can go grab it and try it if you want. Maybe see what kind of high score you can get. And if you get a really good high score, you gotta post it in the comments, the score you got. And don't lie. We're gonna trust you. But yeah, this is what we're gonna make today, and I'll show you how it's done. Ooh, more time. That was close. I had like 2 seconds left. But yeah, if you die, and it's meant to be mobile, so like when you see me drag there, that line renderer I'm dragging out, that's the power that you're gonna see how fast you went. Then if it's just a little bit, ooh. So it was meant to be mobile, like you drag your finger across a phone screen or tablet or something. But anyway, let's get into it here. So again, it was a back burner game because it didn't have an ending when I stopped. I had originally made it because I wanted to make a 2D game at the time that I did it. This was probably about, I don't know, 6 months ago or something like that. And I was challenging myself to do like a personal game jam. I wanted to create a game I could finish over the weekend. And I said, well, if I'm going to do that, it's going to need to be something real basic and simple. And I decided on 2D and the Number Ninja thing, which evolved into this. And I did get what I wanted to get done over the weekend. It just wasn't finished. There was no way to really end it. When the timer ran out or you lost all your lives, it just kept going and playing. You could play forever. So it wasn't finished. But that's all it needed was the end. you needed to stop playing when the timer ran out or you ran out of lives, and that's all it needed. So, so I went and grabbed it off my external hard drive, plopped it back onto my PC drive, and started working on it again. And I added that level that goes Ninjapop in the beginning, and then goes to this level, and you can play. And then when your lives run out or your time runs out, it just goes back to Ninjapop and starts over. So there's no menu or anything. So if you get it, you need to just press escape during gameplay to get out of it. Which is like the universal button to say get the hell out of here. So most people will figure it out if you don't know. And yeah, let's start. Why don't we start by looking through the hierarchy and seeing what we got? We got our main camera, okay. Global light 2D because it's a 2D scene, so we use a global light. Post-processing effects, what are we using? Just bloom, okay. And we got a high intensity. I want those uh, lanterns to glow. Then we get the music that plays in the background. Then here, the drag controller. This is in charge of moving your mouse or obviously a mobile your finger to create power to launch the ninja. Okay. And then this right here, head. All right, this ninja you see, he's not actually the player. He's this guy. And all this guy is a visual element to show you where you land. Okay. And to start from when you launch him off again. But he's not the player. He's just a visual element to show you where you are. The head is the visual player, and he starts off not active because you're not launching him off instantly. So if I make it active, you can kind of see him, and it's just the head. And the head has an animation on it. If I go down here and I click play, you can see it just spins around like he's doing a roll, which works out really good. It's like he ducks down, does a roll, and shoots. And what he's got on him is the sprite renderer, so you can see it. All right, he's got the animator, which we turn on when he's in motion. The circle collider. Okay, so let's turn this back on so I can see it. The circle collider. Okay, so we can make contact with the balloons and stuff. The rigid body 2D, so we can add force, and it's got a physics material I called bounce on it, so we can like bounce off walls and stuff. And then he's got a collide script. Okay, this collide script can access the main score, which is up here, and the pre-score, which is down here. And the pre-score is when you're flying across the screen and you're making contact, all those points add up to your pre-score. And when you land and that launch is done, that pre-score goes up to your score and then returns to zero. Okay, so it's kind of like while you're in the air score. All right, so let's get the reference to the pre-score. Uh, X, that is the multiplier. And I think is this it? No, that's not it. X holder? No. Where is it? It's got to be this, right? Yeah, there it is. Yeah, the X holder has the two text objects with the X and the zero to start. And that's the multiplier object. So every lantern you come in contact with, the multiplier will go up by one while you're in the air. And then when you land, that pre-score is going to be multiplied by the multiplier. So if you got like 100 for a score and you did it in five lanterns, five is going to be your multiplier, and the score 100 will be multiplied by five. So you'll get a score of 500 for that instead of just 100. So that's the multiplier. Let's see where were we? The head we were on. We got to make him not look again. The lamp spawner, obviously, in the name, it spawns all the lamps that shoot up. And it doesn't matter where it is. I can put it over here if I want. But it's got a script, spawn lamps, okay? And we'll see all that in a minute. And it just spawns all the lamps that come up. Right now, we're just looking through the hierarchy, so you'll see what we have and what you'll need. Score is the main score there. And, you know, it goes all the way back to here. So, I mean, you could just get a ginormous score out of that. But really, I should stop it at the head. So let's do that. Let's move it over here. Yeah, let's stop it at the heads because you're still going to have trillions there. All right, so that's the score, is the main score up top there. Then the pre-score and the lives over here. And the lives are just images that I placed on the screen, and then I placed them into an array that the game manager has. Okay, it's an array of game objects, and each one is, you know, like this one, this one, this one. All right. And if you die, it simply goes through that array and it makes that not active anymore. And it reduces your live count, which is an int, I'm sure. But like I said, it's been about 6 months since I worked on this, but it has to be an int. And it will reduce your lives count down one when so that's what that would do. And then the Xholder, we already talked about that. And then the game manager, like I said, it deals with the timer and the number of lives, and it has the array for the images. And then the timer, obviously. The ninja, which is, again, he's just a kind of a placeholder for where you land, so you can see him. And then this text is the Ninjapop text. And originally, like I said, it wasn't finished, so I put this here, but we really don't need this anymore because it's on the new scene I created. So we can get rid of that. And then the level itself is what's in the level. So as you can see, we've got the walls that stop you from flying outside of the screen and that you would bounce off of. And as you can see, they're just colliders like this one here, like this one here. It's just a collider, a box collider 2D. The sprite renderer is turned off for it, so you can't see it. So it's just a box collider. It's not a trigger or anything. When you hit it and collide with it, it kills you and takes away a life. So that's the walls. And then it's got the two stone tablet things you stand on here, which again, just have the box collider 2D, not a trigger. They have the sprite renderer enabled so you can see where you landed. That's those two. And then the background image. Okay. And I had AI create that, so I wouldn't get copyright effect. I think you can get copyright from AI images too, but I think you got a better chance than just grabbing one off, a Google image search or something. So, so that's all that is, the background. So that, oh geez, get the hell out of here. That is what's in our hierarchy, in our scene. Okay, we went through all that. So why don't, why don't we go through this step by step? Um, let's hit play real quick here. So when it starts, you simply, at that point where you start from, and you can see the placeholder guy, and then you drag your mouse or your finger to give it power. I want those katanas. game is addicting. I'm sorry, I gotta play it a bit. Oh, katanas. Yeah, look how they increase your range. So you got katanas you can get to increase your range, and you'll keep them until you die and regenerate. And then you've got some that have throwing stars, like that one. Let's see if we can get it. But you got, there's a player up. See, my player went up there. Timer. Yeah. Oh, look at that. We're back to a minute. Okay, so you get the throwing stars, and what those do is when you connect to them, it just throws stars out in all different directions randomly. And the stars don't, when they connect to something, they don't add to your multiplier count. You have to do that yourself, but they will add to your score, which is the good part about them. And then you get the timers that refill the time. And there's player. They're mostly tens, which suck, but you got some hundreds. Ooh, player. Ooh, that was close. Look at that. So the tens, you really, they don't do much. There's a couple of hundreds, but there's 1,000.1 that comes up. There it is. And if you get that with a multiplier, boom, it just ranks you right up. Stars. So, and then, yeah, pop. If you die, the time ran out. Okay, so to make this, obviously, if you want a background, create a background and throw it back there. Then just create some walls or some boundaries for your player that, like, if you want to kill one, have it down there where he can connect to die. And let's look at the code. All right, so level loader. I just created this when I created that level to say Ninjapop and start the game. And it's just got an audio source called sound, a public audio clip called nin, two game objects, which is the logo and then the animated logo. Here, I'll show you that. Open the scene. Okay. So this is the scene I just created before making this video. And I brought that Ninjapop text over here. Okay. And that's the logo that starts. And then I've got an animated one. So right here, it'll start and you'll say Ninja. Okay. And then in the code, you got an I enumerator. So in the start function, it just plays the it gets the sound component. Okay. So your audio source sound equals get component audio source. That's in the start function. And then it starts the coroutine starter, which is down here. And starter, it waits for 1 second and then plays the ninja sound, which is attached to the audio source. So all I have to do is say sound.play. I don't have to declare a sound or anything because I dragged that sound right onto the audio source right here. So I just dragged that sound. He says ninja, okay, and he'll play it right off the bat. Well, no, wait a minute. It's not set to play on awake. Oh yeah, sound.play. So yeah, wait a second, then he plays the sound because if you just have it play on awake, you might not hear it while it's initially loading up. So I wait a second and I play the sound that is dragged onto the audio source. And then you wait for one more second and you play pop, the pop sound, and it's sound.play one shot. So I declared a clip and I put that pop sound for that game object. I'll show you. And that would be pop. So if you go to the level loader, the script, It's the pop sound. Nin is pop. So it plays Ninja and pop, and then it sets the logo active to false and the logo pop active to true. Okay, and that's what I was showing you. So this is the logo, but after it says Ninja, it waits 1 second and then turns this off and turns this one on. And that one is just animated to pop up. Okay, and it plays that animation. And then after it plays that animation, you wait 1 more second for it to finish, and you use the scene manager to load scene sample scene, which was what the actual game was on. So obviously you need Unity Engine.scene management in this code, so you can do that. So that's the level loader script, okay? And then once the level starts, okay, once this level starts and you're able to play, the game manager right here, okay, let's go find his code, GM. All right, so the game manager, once the game starts, we have the public class GM for game manager. We're using scene management here and text mesh pro. So you need these. We have a public text mesh pro text, which is the timer. So we can declare what the timer is. The timer is here, and we drag that into there. You know what I mean? So we drag that timer object over here. Okay, it'll be this one time. So let's see if I drag it over here. Same thing. So you drag over your text, that's the actual time. This obviously the timer is just a game object holding that text mesh pro text input time thing. Okay. So yeah, this is a big one because I'm explaining the whole game to you. I'm sorry if it's going to take a little bit. So the game manager, when you first start the game, it's got the timer text it could change, and it starts counting down the time. All right, and it's got a game time, which in the script on here it's at 0, but when the game starts it sets it to 60. And then you've got it manages the number of lives, which are right here, which we explained, and that's what the game manager does, and that's what happens when it starts. The score and pre-score or in-flight score are set to 0, the timer is set to 60, and then the 5 images um, are all made to set active because you want 5 lives to start, and the game manager does all that. Okay, so we're using these. We've got the public TMP text timer, which I showed you. The public int for game time, told you it was an int. Okay, and then a public int for number of lives, which is 5. And then a public game object array called lives. Okay, down in the start, we set the game time to 60. We start a coroutine called countdown, which we'll get to. And then we run a function called calculate lives. And instead of just setting them to 5, I use calculate lives because you're going to use this every time you die, this function, to calculate how many are left. So I simply put that there. In the update, since Game Manager is always running this update, I put the code to quit the game. So if input get key code down escape key, then quit. And that's for the published game. It won't do anything in the Unity editor. And then you get a public void calculate lives, which we just talked about up here. It sets the lives. We do a for each loop through the array of game objects. For each game object, life in lives, which is what we call the array lives. This variable life set active false. So each little image you saw up there goes away. And then we do a for loop, integer I, which is just a variable I you create, equals 0. I is less than number of lives, I plus plus, and we set them all to true. So this is basically just to start it with 5 lives, but it also, if you lose a life, it'll do this and then say, oh, you've only got 4 lives. Well, then we'll make 4 of them true. Or you only have 1 life left, we'll just make 1 of them true. That's what calculate lives does. Okay. So you get the for each, turns them all off to start. So you have a starting point for your for loop, and then check to see how many are there. Okay. So how many are active is what it's doing. So lives I dot set active true. Okay. So if you have 1 life, you know, it'll set 1 true. And then the I enumerated countdown, which I showed you, it just the while loop inside of a coroutine, which is called an I enumerator. And it checks to see while game time, the int we talked about, is greater than -1. So it lets you actually get to 0 before going to -1 and saying, hey, timer's all done. So in this while loop, we check the game time, timer.text equals game time to string. That way we can put our int onto the text object on the screen. Then we do a yield return new wait for seconds, 1, because 1 second equals 1 second of our timer. And then we subtract game time after this wait by 1, minus equals 1. And if the game timer runs out below 0, then this I just added before the video, scene manager, load scene, begin here. That's the scene I just made. So it has an ending and a beginning. Okay. So yeah, if the timer runs down to 0, scene manager, load scene, begin here is what it's called. And that's what the game manager does. All right. And of course, your ninja here, this guy, is just sitting here waiting for you to use the drag controller and click and drag some power. And when you do, he'll be set active to false, so you won't see him, and it will set the head active to true, add force in the direction of your drag. Okay, so the drag controller, again, it has the drag control script. The line is the drag controller line renderer, which is right here. So you could just drag that up there after you add it. Okay. It's just a game object, an empty game object that I dragged the script onto, and then I clicked add component and added the line render to. Okay. And as you can see, it starts off small and then goes down to basically nothing. So it like weans out to a point. And that's basically that. So we get the drag control script and the line renderer. And then it gets the rigid body, the RB, the head. Okay, that way you can add force to it. A drag limit, and then a force to add. And then the ninja, which is this guy. And then the head, so we can like make him not visible and make that visible. And then the head position, so we can place it where we want. Okay, which would be from where he is. So if we go into the code there in drag control, and if I go through this too fast, just pause it at a point so you can copy this stuff and paste it, because eventually you're going to see the whole code as we go down. So just pause it, write what you need to write, and then play it again and get to a point where you can pause it and, write that down. Okay, so drag control Here's our line renderer we talked about. Here's our rigid body we talked about. The drag limit, we put to 3. And public float forced to add is set to 10. The private cam, because we want to tell it to follow the player head. Private bool is dragging. Okay, and we use this to determine if we've let go of it or not. So it's to let us know when to add the force and stuff. Then we got 2 public game objects for the ninja and the head. So the placeholder ninja, and then the head that is the actual kind of player. And then a public transform for the head position. So we can place it, where we need to. Then you got a vector 3 mouse position. Okay, and it's get vector 3 position equals cam dot screen to world point input dot mouse position. Okay, so it gets where your mouse or finger would be in relation to where the camera is looking at it, basically. Okay, and then it sets the position Z to 0 and it returns the position. All right. In the start menu, cam equals camera.main, line dot position count equals 2 because we've got a starting point where we click and an ending point that we drag to. So we got line dot set position 0, which is where we click, vector 2 dot 0, and a line set position 1, which is where we end, vector 2 dot 0, line enable false. All right. In the update, we check with an if statement, if get mouse button down, and that would be the left mouse button. I switch my mouse buttons. I use right for left and left for right. So I'm never sure. So it's either left or right, whichever one I'm using. For me, for you it would probably be right. For me, no, for me it's right. So for you it would be left. So this would be left. Input get mouse down. It checks to see, and is dragging is not true, then drag start. It runs that function. And if dragging is true, then it runs the drag function. Okay. And then if you let go of the mouse and is dragging, it doesn't end. So we've got a function to start the drag, while dragging, and when you're done dragging. And that's these. So drag start. We enable the line so you can see it. Set the bool is dragging to true. And line.set position. 0 is the mouse position. The starting point is going to be the mouse position. And then we got this void drag, which is while you're dragging. Start position equals line.get position 0. And then vector 3 current position, which is where you're dragging to, equals the mouse position. And then line.set position 1, current position. And then in the drag end, when you let go of the mouse, okay, this is where the magic happens, and you send the ninja spinning off into the stratosphere, getting popping lanterns. We set the line renderer enable default so you don't see it anymore. We set is dragging default because we let go of the mouse, we're not dragging anymore. The start position vector 3 line.get position 0 and vector 3 current position equals mouse position. We get to have those. And then it checks to see if the current position is less than the start position. And if so, the ninja.getComponent sprite renderer flip x equals true. And that's the placeholder ninja. And it's just set to make him face the direction you're supposed to be facing. And that's what those are. And then ninja else get flip x false. Okay, so it flips the x of the image. So he's supposed to be facing the way he's supposed to be facing when you land. Then we got a vector 3 distance equals current position minus the start position. Okay. and then a vector 3 final force, which is the distance times force to add. So that's how we determine, like if you drag it for a long time, then the distance times force to add means you're adding more force because you dragged longer. And then if you only drag a little and let it go, the distance variable is very small, or the vector 3 of it is very small. So it's a small amount of force to add. Then you get the head dot transform dot position, which is the player, the head, the player that spins and jumps through the air. So it gets his position, and then that sets the head active to true. Okay, so the head's position is going to be set to the player's position, so it looks like the player rolls up in a ball and jumps. And then the head set active true, head.get component sprite render enabled true, and the placeholder ninja graphic is set active to false. And then we add force to the head to send him flying up in the stratosphere, rb.add force. So we do minus final force, which is what we did up here, final force. Oh shit, my mouse just died. Hold on. I plug it in. There we go. Okay, so yeah, the final force we have to do minus because when you drag, we don't want to add force in the direction we're dragging. We want to add force in the opposite direction to launch them out. So we do minus final force, and it would be force mode 2D and impulse. That way it just does it once. It's not like a continuing force. It's just an instant force that is just once. Okay. And then I had this, and I'm not using it, and I'm not sure why. Because, like I said, again, this was a back burner project, and it's been about 6 months or so. So obviously, I'm not using this I enumerator, so I wouldn't put that in your code. And in fact, I'm going to well, I might use it somewhere else. But yeah, since this is commented out, I wouldn't add this. And if you get some kind of error that says you need collide big, just add it. It's right here. But yeah, I don't think we need this. And in fact, I'm so positive I'm going to get rid of it. Or, to be safe, let's comment it out. Because I don't think we need it. Okay. And let's prove it by trying it real quick and seeing if there's a problem. Okay, everything's fine so far. Now, since it said collide big, I want to see if it had something to do with the katanas. So let's wait for a second until we see katanas. Dead. Oh, katanas and a 1,000. Okay, so now we have the katanas, which increase our range and our hitbox. And yeah, no issues, so I didn't need that. And it's still fine. Okay, so again, that's one of the things, that's one of the downsides to restarting a back burner project. You forget what you were doing. And for me, one of the other major problems can be I'm real bad at naming things, and I kind of go with what's shortest at the time to save myself time. And if you come back to a project 6 months or a year later and you do that, you don't know what a lot of these things mean. And, it takes you a lot of time looking through your code and game to figure out what you did. So, excuse me. So that's one of the downsides, I think, to back burner games. But I think the pluses definitely outweigh. Excuse me, I'm sorry. I think the pluses definitely outweigh the downfalls. Because again, one of the main pluses too is you learn from these back burner projects. You learn things. It's like learning from your mistakes, and back burner projects aren't mistakes, but you learn from them. And it's a great learning experience to make these, and not even if you don't finish them, you learn a lot. Okay. So where were we here in code? We were talking about the drag control. Okay, so that is that for the drag control. You get to see all the code, and that, like I said, you put an empty game object in the scene, drag that code over to that game object so you have it like this, and then you just fill in all your items you need to declare. Like since the line renderer is on this, you add the line, you just drag it up here. So after you drag your script, just make sure you add a line renderer component and then add it to your line there. And the rigid body, just drag over this would have been the head. Okay, so you just drag your head over here like this. Okay. The drag limit, the force to add, that's just showing because it's public in the script. You don't need to drag anything over there. The ninja, it's just, you know, this guy. So you just drag him over there, the head, drag it over there. And then the head position, the circle, okay, is on the ninja itself. And that's where we create the head. Well, not create it because he's already created. He's always there. But that's where we place him to start, is above the ninja because we're launching him out, you know. So you just create another game object. For me, I guess it was a circle sprite. Then I took the sprite renderer off, and so it's just a transform. But really, I don't need this component. I could get rid of it. Um, So again, see, we're making this better as we go. As I'm teaching you how I did it, we can make it better because really you don't need the sprite renderer for this. So let's get rid of it. Remove component. Okay. So now it's just an empty game object with a transform, which is all we need from it. Okay. And you can see it where it is because that's where we want to launch the head from when we add force to it. All right. So that is the drag controller, and that's the component for it and what you need to do to get there. And you've already seen the code for it, so you're good there. And like I said, you get the lamp spawner. Let's go look at that code. Spawn lamps. Here we go. Okay, so we got a public class called spawn lamps. There's no extra usings or anything, so you're good there. In start, we start a coroutine called lamp loop because it's going to loop forever until you die. And the update, we don't need it. There's nothing in it, so get rid of it. And then this coroutine lamp loop, enumerator, is a while loop, while true, which is all the time. Okay. Well, until you die, because, you know, once you load that beginning scene, this will stop. So in the while loop, we have transformed opposition, and this is for the lamp spawner. Okay. Transformed opposition equals new vector 3, and it sets the position. So it's moving the spawner, okay, object, which is right down here I showed you. Okay. So again, it doesn't matter where I put it because the code is going to put it somewhere in here randomly. Okay. So transformed opposition, new vector 3, random dot range, minus dot 4 and 4. Okay. So if you look at it up in the inspector here, if I go over here, 4, I mean 4 and minus 4. So in between these pillars is where it's going to spawn a lamp that's going to float up. Okay, transformed opposition, random dot range, this transformed opposition dot y, because we always want it to stay at the same y position. And then we instantiate a lamp at the transformed up position that we just picked randomly and give it a quaternion identity so it has the original rotation that it would have had from the prefab. And then the standard yield return new wait for seconds, which is how often you're going to spawn lamps. Now, you could put this in, say, like a public float, and so you could change it in the inspector or something. But for me, when I made it, obviously, I felt that 0.3% of a second was enough between lamp spawns. Because again, they're mostly like 10 and crap, and you know, so you want a bunch of them. But that is the lamp spawner code because we saved it. All right. So again, what that's going to do is spawn a lamp. The lamp is a prefab. So I created a prefabs folder, and here's the lamp. Okay. And on that prefab, we have our transform, the sprite renderer for the graphic, which is lamp right there. Okay. We got a box collider 2D so that the Ninja can collide with it. And it's set to a trigger. And this is important because you don't want to just collide with it. It would basically stop you with your movement. Okay, you want that to be a trigger so you can go right through it, and it can detect you that way, but not stop you from moving. So you can collide with other ones. Okay, so that's important. It needs to be a trigger. All right. And then you've got the lamp script, which I wrote, which has a value. Okay, so if you look at the lamp, uh, what's the prefabs? Let's bring one out. Okay, so if you look at the lamp, what I did was I added all the things you can get for it onto the prefab that you create. All right, so there's the Ninja Star, there's the katanas, and there's the timer. And here's the value up here. Okay, so that text is what we just saw for a value. It starts at 100, but the script is going to tell it what to be when it starts, really. Okay, that's just for visuals right now. Okay, so you get the value, then you got a particle glow, particle system, that's the little sparks you see coming out of it. Okay, a time add, oh, that's the clock you see right there, which adds time. Cat for katanas. All right, the head, what is this? Uh, oh, okay, that's the star. All right, no, that's the star. Where's the head? Oh, the head is for the extra lives. So, okay, so it's got all the things that can come up on it already attached. And that's the prefab, okay? And this is your script, which is right here, okay? So we don't need that in the scene. We'll get rid of it. Go back to the code. So like I said, we initiate the lamp. And then we go to the lamp code, okay? Which is attacked, attached to the prefab I just showed you, okay? And we're using Text Mesh Pro because of the value there. So we get the value, the time add, which was the head, I mean the clock, katanas, which I showed you was katanas, life, the game object is the head, obviously, to add a life, star is the throwing star, and then PS, what the hell is a PS? Particle system. Okay, now see there, when you have back burner projects and you name stuff like PS, come back to it a year later, you're going to be like, what the hell is PS? What was I thinking? So yeah, the particle system. Okay. So we have a public game object for the particle system, a float for wind, or that I called wind, which is going to be because it randomly floats side to side, and that's what the wind variable is for. A private int v equals 10. Don't ask me why I named it v, I just did. I probably had a reason at the time though. And then in your start method, time add set active false, katana set active false, life set active false, star set active false. All those things I attached to the prefab, I set inactive so you can't see them. Okay. And then don't ask me why I did this, but I did. Float I equals random dot range 0 to 100. I random dot range 0 to 100, and I the same thing. If I is less than 20, v equals 50. Okay. Oh, it's v, it's a value. Okay. So the int v is equaling the value of this randomness that is going to tell us whether we create the katanas, the clock, the life image, the stars. That's what that value is for. So if this random dot range I is less than 20, we create the value to 50. If it's less than 10, we create the value to 100. And if it's less than 100, we create the value to 1,000. So that's that right there. And then again, we check the values to see if II is less than 5 and II is greater than 2. So if it's between 3 and 4, then we add a timer clock to it. The one that's already on it, we set it active. And that way you can add time to your game. And that's what all these do. So if II is less than 2, katana is set active true. If triple I is less than 5, see, that's why I did, I think, the different floats, because there's different things you want to set active between the timer clock, the katanas, the throwing star, the extra life. I think that's why I did that. So I'm not using the same variable random generation for each one. All right. And then destroy game object after 10. Okay, so after the lamp is created, it's got 10 seconds to live. That lets it get off the screen if you have not connected with it before it's destroyed. Okay. And then wind equals a random dot range of minus 0.5f and 0.5f. And then my value dot text equals v to string. So that's the value point-wise we discussed. Okay. Um, Originally, it's set to 10, but if your integer, I mean your float here, is less than 20, we move it up to 50. If it's less than 10, we move up to 100, and if it's less than 1, then we give it the 1,000 points. Okay, and then in the update function, transform.position equals new vector 3, this transform.position.x plus wind. Okay, so that way it has a randomness to its movement times time.delta time. And then we do transform.y plus 2.5f times time.delta time. 2.5f will be the speed times time.delta time that it floats up. Okay. Then we have this private void on trigger enter 2D, which checks to see if the head, which is actually the player, collides with it. And if so, if collision head, then we create an integer called tempv, and we equal it to integer.parse collision.gameObject.getComponent collide dot prescore dot text. Okay, so we're getting the prescore text, which is the in-air point system I showed you that adds to the actual points when you land. We're getting that from the collide script right here. Okay. And then we take that temp v plus equals v. Okay. And then collision.gameObject get component collide dot prescore dot text equals temp v to string. Okay. And then again, collision.gameObject collide dot multiplier plus equals 1. So this is that every time you collide with a lantern and take it out, your multiplier goes up by 1. That's how we know how to multiply the in-air score by the multiplier to add to the main score. Okay. Excuse me. And here we go down after that. If time add dot active in hierarchy. Okay. Game object temp. I'm creating a temp game object here. And I'm equaling it to a game object that bind game object with tag GM. That's the game manager script here. Then temp.getComponent GM, which is the script right there. Dot game time, we're changing the game time here. If temp get component GM is greater than 60. So in other words, if you get a clock, let's say you're at 41 seconds. And hold on a second, I gotta light my cigarette. Yes, I smoke and I know it's bad for me, okay? So yeah, what we're doing here is if let's say you, like I said, you're at 41 seconds and your player gets that lantern with the clock on it to add time. Okay, you don't want to add time that the the amount of time you can get for one of those is 30 seconds. Okay, but if you're at 41 seconds, you want it to be the max of 60. You don't want it to go over 60. So let's say you're at 40 seconds when you get it. If you added 30 to that, you'd get 70. You don't want that. You want it to stay at a max to make it challenging. So what I do is I check that if it's greater than 60, I set it to 60. That's what that does right there. All right, and then the katanas. If katanas.active in hierarchy, collision.gameObject get enable katanas. And this enables them on the head. Okay. It's getting the collision game object, which is the player, the head. And if my katanas were active on that lamp, then I make them active on the player. Okay. Same with the life. If the collision game object and the life is active on the lantern, then it adds a new life. And same with the star. Okay, that's what these do. And then instantiate the particle system. It instantiates the particle system that I showed you at my position and rotation. And then it destroys the game object because we collided with it, so it should go away. So that's the lamp code. You've seen all of that. Okay, and we discussed collide in here. So let's go look at that code. Okay, so in here we're using TextMesh Pro and Scene Management. And we get the class collide. And we've got a public TextMesh Pro text, main score. So we're getting a reference to that main score text, the pre-score text, the X multiplier text. Okay, we're declaring a game object X holder, which is the empty game object that holds the text for the multiplier. We get the reference to the integer of the multiplier itself. Public game object Ninja, who's the placeholder that you see standing up. The public game object poof, which is the particle effect, which is like that purple poof of. See, I'm talking so much, my freaking cigarette keeps going out. Hold on. should have smoked before I did this video. Okay, so the poof is just the particle effect that you see when after you die, it does that poof of gray, like purple smoke right before it puts the ninja back up there. Okay, then it gets a reference to the game manager game object, uh, the rigid body 2D of the star, um, the throwing star. It sets this transform, which apparently I'm not using. And that's funny, actually, while we're talking about it. When I first brought this game onto the desktop because I wanted to finish it, I tried playing it and I got a null reference exception from this line right here, SP position. And I said to myself, okay, well, what's the problem? And I started looking and I couldn't find why I needed this. So I simply commented it out and that error went away. So apparently I don't need you either. So I don't know what I was thinking when I was doing that, but we don't even need a start method here. We can get rid of that. Okay. In the update, okay, and we don't need this, whatever it is, so let's get rid of it. In the update, we check to see if transform.position.y is greater than -1 and weapons equals true. Get component circle collider.radius. Okay, 2 point. So this is checking to see if the katanas are true. We increase the collider radius of the head. Okay. Else we set the radius. So when you're just a head and you don't have katanas, your collider radius is 1. And if you've got the katanas, your collider radius goes up to 2.5. That's what these do in update. Okay. And that's great. It's over double what you start with for just being ahead. So you want those katanas if you're playing for a high score. And then we've got a private void on collision enter 2D, collision 2D, collision. Okay. So if collision.gameObject compare.tag platform, okay, and I'm going to assume that it's the platforms you land on. Let's see. And yes, there's a tag platform and there's a tag platform. Okay. So if collision is the platform, all right, then the x multiplier.text equals the multiplier value to string. So it shows you what you how many of those you hit for a multiplier. And it selects the x holder to set active true so you can see the multiplier value. And then it starts a coroutine to show you it, and it'll eventually shut it off. Where is it? Yeah, it'll show you X holder set active false after 0.2 seconds, which is kind of quick. Let's go 0.3. And then it sets it false, sets the multiplier back to 0, and sets this game object to false. So that's what that does. Okay, if it's a platform. If our head lands on a platform, okay, that's what it does. So it starts coroutine. Then we create 3 integers, temp v, temp v2, and temp v3. Temp v equals integer parse prescore.text. Okay. Temp v2 equals temp v times the multiplier. Okay. And then temp v3 equals integer.parse the main score text plus temp v2. So here we're multiplying what your in-air score was, the pre-score, times the multiplier, and then applying it to the main score. That's what that does. So the main score.text equals temp v3 to string. So now we show the main score going up. And then the pre-score text we set back to 0, 0 to string. Ninja transform.permission. I can't talk today. Transform.position equals new vector 2. This transform.position x and ninja transform.position.y. Okay. What this is saying is wherever we land, that's where we want him to go. And he's not visible while you're in the air. So once you land, it sets him to where you landed and makes him visible. Okay. And it keeps the same Y because we always want this guy to be at the same vertical position, Y, his Y position. So where he is now, he'll be at that Y position over here. That's what that does. And then we set him active to true because we landed, and you can see him again. Okay, so we get the sprite renderer, get component sprite renderer, and we enable it to false, and that's the head. Okay, so all this should be on the head. Let's go see the head. See, the head has the collide script that we're looking at right now. Okay, so when I say get component circle collider 2, that's from the head. Okay, so we set the sprite renderer to false on the head because now we see the standing ninja there. We don't need to see the head anymore. Set it to false. And then we set this transformed opposition to a new vector 3 of 0 and 5,000. Get it out of here. Okay, I don't even want it on the screen, is what I'm saying. It doesn't need to be. Then we get component circle collider 2D and set its radius to 1. Okay. And then in this if statement, if collision.gameObject.compared to death, and that is the box down here. Where's the walls? That's this box here. Okay. See, it's got the tag death. So if I collide with that, I'm dead. So if I collide with the death box down there, then it checks to see if the game manager number of lives equals 0 or not. Okay. And if it does, and we have no lives to keep going, we simply take the scene manager, .load scene, begin here. And we go back to that Ninjapop scene, which will in turn start the game again. And then return so that no more code is run after we do that. And that's if there's no lives. Okay. But obviously, if there is lives, we go to the game manager, GM dot number of lives minus equals 1. We subtract the life. And then again, the game manager GM dot calculate lives. We run the calculate. So it can show visually how many lives we have. And hold on a second. I don't know if you can tell by my voice, but I'm thirsty. I need some coffee. This is a long one. All right, so ninja.transform.position equals new vector 3. The death, this is the starting point for that ninja. So if you go through the middle, okay, if you jump and go, and hit down here, he puts you right back here. Okay. So if we look at them, that's what your position is, -7 and -4, X and Y. So if you die, boop, you start right back at the starting point here. That's what that's doing. And then this transformed opposition, okay, so this would be the head, is again off screen. I don't want it anywhere near me. I don't need it. All right, prescore dot text. We set it back to 0 because we just started over again. There's no, it should be 0, and the multiplier to 0. Okay, and then this dot game object, the head, set active false, ninja set active true. Okay, so again, this is if you collide with death and you're respawning. This is what happens. Set ninja back to true. Then instantiate the poof. That's what I was talking about with the. Let me show you real quick. It's just a particle effect, particle system. So let's say like this. Watch. Poof. Okay, that's all it does. All right. So what's I? Death. Yeah, instantiate poof, and we put it at the starting position. So it looks like he's kind of poofing in like a ninja would. And then we get component, circle collider 2D, radius 1, that's the head. Okay, so we set the radius back to 1 because we've lost our katanas. If we died, we lost our katanas, if we even had them. So either way, we set the radius back to 1. We don't have katanas anymore. Then we set the weapons default because we don't have katanas, and the katanas defaults because we don't have them. Okay. And then we've got an I enumerator to show the multiplier text. All right, so it waits a second and it sets it all to true. X holder set active false, multiplier 0. So show X, it waits 3 seconds, okay, and then it turns it off. And then we got this collide wait, yield return new, wait for seconds, 0.5F. That's a coroutine. And then we've got enable katanas. Katana set act true, weapon set act true. So clearly, when you collide with a lantern that has katanas for you to get, it runs this function. It sets them to true and set weapons to true. And same for add life, shooting stars, ninja stars, same thing. Um, and this is, if you connect, all right, it doesn't have to really do anything like this. What it does is it creates those stars at your connection point and shoots them off in all random directions. And that's what I was showing you with that. So we start off with an integer I equals 6. We create 6 stars. Okay. Float R. Okay. And that's probably rotation. And I say probably because, again, back burner project. I haven't done this for a while. And then in a while loop, I is greater than 0. Okay. While I is greater than 0. The rotation equals random.range 0 to 360. And then the rigid body 2D of the throw star, we create rigid body 2D throw star. Okay, so we're creating like a variable to instantiate the star so we can access it with this variable. Okay, and we create it at the position that you got the lantern, and then the quaternion.euler, its rotation, but the Euler is x0, y0, and z is going to be the r values 0 to 360. Okay, and then we add force to the throw star we just created, 10 times transform dot up. Okay, and that's going to be from the rotation that sets it the up. Okay, and then again, force mode impulse 2D because it's just one force that you don't want continuing in a loop. So obviously, there, the throwing stars have a constant force of 10. Okay, not constant, but if you create stars, it's always going to be 10, and it plays just once in that impulse force mode. And then I minus minus. That way, we create 6 of them. So if I is greater than 0, it's going to create another one and then do the same thing. Give it a random rotation and then add force in that rotation from its forward direction. So that's what that does. And then I minus minus. So once you create 6 of them, that ends, you'll return null, and that ends that function. Okay, and then we have a public I enumerator shoot stars 2. And what is this here? You know, shoot stars and shoot stars 2. I'm probably only using one of these. Let's find out. Let's go see a star. All right, so we need that lamp back up here. And the star. Do you have any code on you? No. Lamp script. Let's go see the lamp script. Before we do, let's get rid of this because we don't need it anymore. Okay, so on the lamp script, okay, so shoot stars is what happens when you get a lantern with a throwing star active on it. Okay. So clearly, shoot stars too, not needed. It's never activated. So I'm guessing this was, well, all right, you know what? We're going to test it out again. Let's comment all this shit out. And I'm sorry I'm doing this one by one. I don't know how to, oops, do the whole thing at once. Okay, so we commented that all. We shouldn't need that. File, save all. Let's see. Give it a test run. But obviously we're going to need a star. The timer. Oh, poof. All right, come on, give me a star. Once it does, then I have to actually connect with it. So katanas would be nice before the star. Well, the star. Okay, so yeah. I didn't get any errors or anything, so clearly did not need that other one. So let's get rid of it. Don't need it. Goodbye. Okay, so that's the collide script in its entirety. Save it. And the collide script is attached to the player, the head. Okay. Man, this is the longest. I think this is one of the longest ones I've made. Videos. I don't like it. Okay, so what else do we have to cover to make this tutorial so you can just create it yourself? I'm not sure. I think we've covered everything. I mean, you got the score, the pre-score, you got the timer and the heads, and we've explained all this stuff. I explained how the level looks and works. I've explained about him just being a placeholder and the head is the actual thing. I think I've got it all. I don't think. I mean, we've gone through the level loader that, loads the sample scene and the stars. What is this? Not sure if we even use that or not. I don't think we use this. Yeah, you might be able to ignore this. I don't think we use it. Again, like I said, I made this for like a personal game jam. I did it over a weekend. So it was very chaotic and hectic. And I might have started something like that and then said, oh, I don't, I figured out a better way to do it. And I simply didn't get rid of it, because getting rid of things takes time. You don't want to do that during a game jam, even if it's personal or not. So this we probably don't even need, I don't think, because there was no script on the star itself. And the collide script, which is on the head, clearly spawns the stars and adds the force and trying to find it again. The star spawn. Is it on the lamp? Shooting stars. Yeah, so if you glide with a lamp that has stars, it starts that shooting stars coroutine on the collide script. And it's rigid body and adds force. Yeah, so we don't even need stars. Get rid of that. We don't need it. All right. And then destroyer. It's just a script to destroy a game object, and I'm wondering if we need this too, but we probably do. And my T is probably my time equals 3. So destroy game object up to 3 seconds. So this clearly, if something, I don't think we need that either because it was never referenced in all the stuff we just created that I showed you. So I don't think we need that either. So we're down to the level loader, which I showed you, the game manager, which I showed you. And if not, let's scroll it up now so you can pause. Then the lamp, we went through that, I know that. So let's just scroll through it so you can pause and copy this code. And then spawn lamps, don't even need to scroll, it's that short, is the lamp spawner from down below. And then collide, which is a script on the player head. We'll scroll through this so you can copy any code you need, pause and do it, and make sure you can get it all. And then the drag control script. So we got here, scroll down, pause, put the code in, unpause. Okay, let's just get rid of that. Okay, so to me, I think I've covered everything. If I missed anything, let me know in the comments. If you want to put this together and you run into a problem and say, "Oh man, he didn't do this," or let me know, and I'll update it or I'll try to answer your questions in the comments. But I feel like I've covered everything that went into this game and all the code for it, and that's it. So hope you enjoyed it and that you liked the game. And without a timer. So yeah, that's it. And, if you liked it, please hit the like button. If you've got something to say about it, please leave a comment because, it doesn't seem like my videos are getting out to as many people as I'd like it to. Okay, and part of the reason is, so far I've gotten like no comments on my videos and no likes. Okay, so even if you like it, you're not hitting the like button. And what this tells YouTube is that I suck and that the algorithm isn't showing the people it needs to show, okay, for this channel to grow and get subscribers and get, subscriber base. And so, yeah, please help the channel out, support the channel. It doesn't cost you anything, okay? Like it, subscribe to it, and leave a comment about it. And it tells YouTube that, we need to show this guy's content to more people. Oh, I thought it was dead. Oh, now I'm dead. All right, so yeah, please support the channel, like, comment, and subscribe, okay? And with that said, there'll be a link in the description if you want to grab this for yourself and try it out and see what kind of score you can get. Let us know in the comments what your high score was. And if you, like I said, are creating a game and you come across an issue where I missed something, let me know and I will rectify it. But I think we covered everything. So until next time, peace out.